Hello, everyone. Welcome. I am Jet Aguilar from the Astronomical League of the Philippines, and I will be your host for today's webinar. Thank you so much for joining us for our fifth webinar of our 2022 Astronomical League of the Philippines Astronomy Expert Series. I'm happy to see a lot of registrants attending not only from the Philippines, but from other countries as well, like the United States of America, Puerto Rico, Canada, Japan, Singapore, Malaysia, Indonesia, to name a few. Ever since the dawn of time, man has been fascinated with the presence and beauty of our nearest celestial neighbor, our moon. We have incorporated the moon's regular cycle in the sky to our daily lives, and we know that our only natural satellite plays a very important role to life here on Earth. Today, we are very fortunate to have with us a noted selenophile and astrophotographer who will talk to us on observing and understanding the moon. For those who were not able to register but would still want to watch this webinar live, we are currently live streaming on Facebook at the Facebook page of the Philippine Astronomy Forum. So you can log in there and watch us live now. Before we start the program, kindly allow me to explain some rules for this webinar to help us make this an enjoyable learning experience for everyone. Kindly listen and do your best to give your undivided attention to our speaker. There will be a short question and answer session at the end of the lecture. You may type in your questions under the Q&A tab found in your Zoom interface at any point during the presentation. We'll do our best to read and answer your questions live after the lecture or via the Q&A tab. We would like to remind everyone that the contents presented in this webinar will remain as the individual property of the lecturer and the photographers in the presentation. We will also be distributing certificates of attendance via email to all registered attendees who will be present with us throughout the webinar today. So please use the name you have written in your registration forms to help us facilitate this process. Enjoy the webinar and have fun learning. Here's the program for our webinar today. Let me turn you over now to Ms. Imelda Joson to introduce our speaker.
Thank you, Jet. But before introducing today's speaker, I'd like to thank a few people who worked tirelessly to bring this idea into fruition. First and foremost, to my hubby Edwin, to James, Jet, June, Peter, Kendrick, and Ian, and the rest of the Astronomical League of the Philippines. To many of our friends who wholeheartedly agreed to share their precious time and expertise to the Filipino science community and to the world. And to those of you who join us from the Philippines, the United States, Canada, Europe, Asia, the Middle East, and the rest of the world. We are very honored today to have a speaker whose books have been a tremendous help and inspiration to both Edwin and myself through the years. It is my great pleasure to introduce our friend, Robert Reeves, whose interest in astronomy and who have so passionately been enlightening others about the subject through his astronomical images, articles, books, and lectures spans over half a century. His articles have been published in Astronomy, Sky and Telescope, Deep Sky Journal, The Reflector, Amateur Astronomy, and The Astrograph. Robert is an accomplished astrophotographer and an author of 4 books: Celestron 76mm Signature Series First Scope bears his moon photo, and his autograph. His lunar images are truly stunning. Edwin and I never failed to wait for his posting on Facebook to see his latest work. For his work and accomplishments in the field of astronomy, the International Astronomical Union named asteroid 26591 Robert Reeves in his honor. Thank you, Robert, for sharing with us your time and expertise, and welcome.
Well, I'm glad to be here. Does my portion of the program begin now?
Yes.
Okay, so I'm going to go to screen share and see if we can launch the program. Okay. All righty. Well, like I said, the title of my presentation today is Observing and Understanding the Moon, and I'm very honored to present it to such a long distance and widespread audience. This is really becoming a new experience for me to be able to speak to such a huge audience across the globe at the same time. So many of my slides will have subtitles in case the audio is not perfectly clear over the internet. My voice isn't the best right now. Many people have seen on the news this gigantic plume of African dust has blown across the Atlantic and landed right on Texas. And it is really bothering us a lot. Everybody is having an awful lot of allergy problems because of it, and it is affecting my voice. So hopefully you'll be able to understand me okay. But you know, the 50th anniversary of the Apollo 11 moon landing is past us, and much has appeared in various media about how we got to the moon, the politics of why we went to the moon, and the personalities of those who engineered, directed, and actually flew the mission to the moon. But half a century after humans first set foot on another world and explored the moon, how much does the average person actually know about the moon? Well, the answer is surprisingly little. So I'm going to try and fix that. I've been in love with the moon my entire life. My earliest memories of the moon were watching moonrise through the bedroom window when I was a child. Now today, 70 odd years later, space age explorations have not stripped the wonder and the mystery I felt for the moon when I was young. Therefore, there is a name for people like me. I am a selenophile, a person who loves the moon. A little background about my involvement in astronomy. In 2000, I published the book Wide Field Astrophotography. It was well received, but photo technology soon changed, and this was the last book written about film-based astrophotography. So we changed gears, went digital, and in 2005, I published the book Introduction to Digital Astrophotography. This was the first book written about astrophotography using a DSLR. Now, although I'm well known for my lunar photography, I enjoy urban deep sky photography with my Celestron 14 and HyperStar on top of the observatory on top of my garage here in San Antonio. Using modern light pollution filters, we can do just as good deep sky photography from in the city now as we used to have to go outside the country, take a 100-mile trip away from the city to be able to do this. So I enjoy the best of both worlds now, my deep sky work and lunar work from right here in San Antonio. In 2006, I published the Introduction to Webcam Astrophotography. Now, this book helped popularize the use of the webcam video capture for planetary photography. And I like to think it helped launch today's planetary camera industry. My moon photographs have appeared in the covers of magazines and appeared in magazine articles, some of which I wrote. My moon photographs have appeared on the cover of science fiction books, as well as technical publications, and they have also appeared in popular astronomy books. And my moon photos are also used by some people who collect astronaut autographs. Imagine that, my moon photographs signed by people who actually walked on the moon. I wish I had one of those pictures, but unfortunately, I have the photos, they have the autographs. And curiously, some of you may be sitting on one of my moon photos. If you have this iPhone case manufactured by Spec that has my moon photo on it. Now, over the past 10 or 15 years, I've spent a large amount of time chasing big telescopes across the southern United States in an effort to take high-resolution lunar photographs. However, I find I can take better images of the moon from my own observatory here at home with 7 to 11-inch telescopes, because the poor seeing that is typical in this region of the United States does not degrade the image in smaller telescopes as much as it does in the larger telescopes. So, how good is modern lunar imaging with a modest amateur telescope? The image on the left is a plate from the famous Kuiper Lunar Atlas. It was the best that professional astronomers could do from the Earth in the 1960s, leading up to the Apollo program. The image on the right was taken from my backyard with a Celestron 11 and a Skyres planetary camera. I'll let you be the judge as to which one is the better image. Now, I like to say I have no special talent. I have no degree in astronomy. I just have over 60 years of experience. So I only claim that I am passionately curious, and I like to explore the universe, but with all the resources that are available to us, the same resources available to anybody else. So I like to think of the moon as my playground. And today I'm inviting you to come out and play with me. Now, when I was young, the moon was a big deal. The moon was a dream, a goal, a destination, a place of mystery to be explored by brave heroes who dared to set foot on another world. Then in the 1970s, there was a fundamental shift in amateur astronomy. The introduction of the 8-inch Schmidt Cassegrain telescope gave us a powerful, affordable telescope that opened up the deep sky to amateur astronomers, and the moon faded from our dreams. Well, the goal of my presentation today is twofold: to bring the moon back within our astronomical realm, to make it not something to be avoided because it interferes with the deep sky, and to get you to look at the moon, not just look at the moon, but to see it and understand it. Today, many astronomers consider the moon boring, a place covered with bumps and holes. But the moon is not visually static. The moon is a geological wonderground that changes day by day, even hour by hour. There is much to see on the moon once you know what to look for. And I want you to go back to the moon with me and rediscover its wonders. So today we're going to look at the creation of the moon, the evolution of the moon's face, the status of the modern moon, and then we'll explore it through a telescope. So necessarily the very first event on the moon was the creation of the moon. Today, the best guess theory of how the moon was created was a collision between two protoplanets early in the solar system, about 4.6 billion years ago. The proto-Earth collided with a smaller Mars-sized body that we hypothetically call Theia. Now, the collision shattered both worlds, but they soon gravitationally accreted and formed the present Earth and our own moon. At the time, the moon formed much closer to the Earth than it is now. At the time of its creation, the moon was no further away from the Earth than the geosynchronous satellites that provide us communication. But over the millennia, I forget the name of the word for billions of years, but nonetheless, over the billions of years, the moon is receding away from the Earth. So currently it is about 250,000 miles away. But early on, it was much, much closer to the Earth. So you can imagine if the moon creates tides like it does today at a distance of 250,000 miles, the fierce tides that it would have created on Earth when the oceans first formed were probably hundreds of feet high. The massive churning of Earth's oceans by the gravity of the nearby moon indeed is partially responsible for the mixing of chemistry that led to the development of life on Earth. If there had been no moon around the Earth early on, we might not be here. Now, the early molten moon, right after it solidified, was still soft. The iron and heavy radioactive elements sank to the center, to the core, and the silicates floated to the top to form a global magma ocean. Now, the vision of a glowing ball of molten rock flying through space sounds good in science fiction, but in reality, the surface was probably black, a chilled shell of solidified basalt, probably completely covered the surface above the molten moon, but it took millions of years for the moon to cool off and solidify. In the time since, the moon has undergone a series of geologic time periods, much like Earth's past is designated by the Jurassic period, the Triassic period, things like that, things we learned back when we were fascinated with dinosaurs. The moon has similar epochs of time. Pre-Nectarian dates from prior to about 4 billion years ago in the formation period of the moon. The Nectarian period was very brief, only about 100 million years old, long, between 3.85 and 3.92 billion years ago. This is the period of late heavy bombardment when the large basins on the moon were formed. And basins are any crater larger than 300 kilometers. And these are seen today as what hold the large lunar maria. All the dark circular features on the moon are actually basins that have been filled with basalt. The Imbrian epoch, 3.1 to about 3.85 billion years ago, was a period of intense volcanic Mare formation. The basins were flooded with series of lava flows. And then the Eratosthenian epoch, from about 3.1 billion years ago to just about 1 billion years ago, is when the post-Mare cratering occurred, where a majority of the craters that we see on the face of the moon today were created. And then the modern era, the Copernican era, about 1 billion years to the present. In this period of time, very few craters have been formed. The cratering rate has reduced significantly. So we're going to take a closer look at how the moon appeared during these times. During the Nectarian epoch, the moon's crust had solidified, but at that time, the crater formation rate was about 300 times greater than it is today. Basically, there was more rubble in the solar system back then, and there was a lot more buckshot to throw at the Earth and the moon and the inner planets. The basins formed during the Nectarian epoch, but there was not yet any Mare-forming volcanism. During the Imbrian epoch, there was extensive volcanism, lava welling up from magma chambers under the moon and slowly flooding the deep basins and creating the Maria that we see today that form the face of the man on the moon. Then during the modern Copernican epoch, the significant reduction in cratering. Fortunately, the moon is, the solar system's kind of run out of ammunition, or it would be an interesting time for us here on Earth with frequent heavy impacts. But during the Copernican epoch, the craters that formed in the past billion years still retain a ray structure, like Tycho and Kepler and Copernicus. This presence of the ray structure indicates these are fairly young craters. The ray structures will fade with time. So any crater that still has a significant ray structure, we figure is probably less than 1 billion years old and firmly in the Copernican epoch. So when it comes to the basic formation of lunar landforms, there's only 2 forces that create the surface features we see on the moon: volcanism and impact cratering, or the modification of an impact crater by volcanism. The 2 forces sometimes work together. The dark Mare features, they're volcanic, basaltic, relatively few craters because they are fresher than the rest of the moon, and they're relatively flat. Now the light-colored highlands is the original crust of the moon, a magmatic crust that is left over from the silicate material that floated to the surface of the moon when it was still molten. It's heavily cratered, relatively rough. So we'll summarize a little bit of our scientific understanding of the moon. Since the space age began about 50 years ago, 60 years ago, the moon was intensely studied for a while, and our knowledge of it just exploded exponentially. But there's still a lot of mysteries about the moon. Now, the moon is not the primordial object we thought it was before the space age. The moon is made of rocky material that has been melted and heavily modified by both exogenic and endogenic forces, that is, exterior and interior forces on the moon. It is not a frozen time capsule of what the solar system was like 4 billion years ago. Two conclusions were drawn about the moon before the space age, and that is the moon underwent a huge bombardment about 500 million years after it was formed. And then about 700 million years after it was formed, volcanic activity began and was prevalent for about 1 billion years. After 50 years of intense research during the space program, the moon remains lifeless. In the lunar samples that have been returned to Earth by both American and Russian spacecraft and manned explorations, no living organisms, fossils, or organic compounds have been found. The lunar evolution process through the accretion of smaller bodies, melting and impacts have left the moon with a crust about 60 kilometers deep and a uniform lithosphere reaching about 1,000 kilometers deep. Below it lies a partially liquid core. We still do not know if the moon possesses a small iron core, but I strongly suspect that it does. The oldest rocks on the moon are the 4.6 billion year old light-colored highlands known as the terrae. The youngest rocks on the moon are the 3.2 billion year old maria formed by volcanic eruptions. The youngest rocks on the moon are thus about as old as the oldest rocks on the Earth. The Earth and the moon formed from the same source material. The Earth and the moon evolved similarly, but the moon is depleted in iron and volatile elements. Lunar rocks formed in high temperature events with little chemical reaction with water. The evidence of the earliest events that formed both the Earth and the moon are now only seen on the moon. That's because Earth has evolved oceans and an atmosphere that have completely eroded and modified all former evidence of the massive impacts that both worlds suffered. Now, lunar rocks can be broadly categorized into three types: the volcanic basalts that erupted from the interior and formed the maria, anorthosites that are the lightweight material that floated to the surface of a molten moon, and breccias created by the mixing of other rocks crushed by meteorite impacts. During the after the molten moon solidified, it was blasted by thousands of asteroid impacts during the late heavy bombardment. This was during the Nectarian epoch. The largest impacts created the basins that later flooded with lavas to form the maria. The primordial moon was also much closer to the Earth than the modern moon. I mentioned that at formation, it was a little further away than our current geosynchronous satellite belt. The crust of the far side of the moon turns out to be thicker than the near side. Most of the volcanic flooding of the basins occurred on the thinner crust near side. It was simply easier for lava to get through the thinner crust and reach the surface. The higher density basalt within the near side basins displace the moon's center of gravity, allowing the moon to enter a synchronous rotation that keeps the same side always facing the Earth. Over the billions of years of its existence, the moon has been blasted by countless meteorite impacts that have crushed the upper layer of the crust into a mixture of dust and rock fragments called regolith. Because impacts because impacts excavate rock samples from deep within the moon's crust, it is possible to analyze the interior of the moon. Now, for the next part of this, we're going to explore the moon through a telescope and understand the face of the moon by taking a close look at the Maria themselves, the mountains on the moon, how they were created, the different types of craters, ridges on the moon and how they were formed, rills or channels in the moon, how they were formed, and various volcanic features. And then we'll go through a telescopic sequence of some of my sentimental favorite lunar features. So the Maria, or lunar sea, is a field of dark basalt deposited by ancient volcanism. The basins on the moon and the Maria lying within them are not the same feature. Basins were created by asteroid impacts. The Maria were formed by lava eruptions that later flooded the basins. And I should point out, not all basins contain a Maria. There are approximately 50 odd basins on the moon, and only about 24 of them actually flooded with basalt to create a Maria. The Maria define the face of the moon and create the caricature of the man in the moon that we can see with our eye as the moon rises. There are 21 named Maria on the near side of the moon. 11 were named in the 17th century by Giovanni Riccioli. 8 were named in the 18th and early 20th, the 19th and early 20th centuries, and 2 were named in the space age recently. A common theme in all of the Maria is they are circular, and that's because they're basically lava-flooded basins or gigantic craters. Craters generally tend to be round, so the theme on lunar basins is they are also round, followed by the lunar Maria being round also. Mare Crisium, very distinctly cradled by the raised rim of the inner basin ring containing the lava flooding that created the Mare Crisium. Mare Serenitatis follows a similar thing. The face of Mare Serenitatis is perhaps the least cratered area on the moon, with only 17-kilometer wide Bessel being the largest crater within Serenitatis. Thus, the Sea of Serenity is very aptly named. It's one of the most serene places on the moon. Mare Tranquillitatis presents kind of a figure-8 shape. My thinking is this may be 2 overlapping circular craters, and we simply do not see the border between them, been flooded with lava. Mare Imbrium appears to be the largest of the Mare on the moon. Gigantic circular feature, almost 900 kilometers in diameter, but it's just a trick of perspective. Imbrium is the second largest. It forms the man in the moon's left eye as we see the full moon, but the largest Mare on the moon is one we almost cannot see. We'll take a look at it shortly. Mare Humorum, another circular Mare filled with basin filled with lavas. There's Oceanus Procellarum. I mentioned this is actually the largest Mare on the moon, but it is off to the west side of the moon, and our view of it from Earth is highly foreshortened. This Mare is actually twice the size of Mare Imbrium, but because of its foreshortened view, it doesn't even contribute to the caricature of the face of the man on the moon. Now, not all basins completely filled with lava. Mare Orientale in the southeastern portion of the moon is near the thicker far side crust. So the lava eruptions were not as intense, and Mare Orientale essentially is a collection of lava-filled craters instead of an entire basin filled with lava. And not all Maria filled a single basin. Mare Frigoris is 1,800 kilometers wide. Sorry, that dust is getting to me. My voice is starting to get funny. Mare Frigoris is 1,800 kilometers wide, but is only 200 kilometers high and may lie in portions of the Procellarum, Imbrium, and Ceratotinus basins. Yeah, this dust problem, dust blowing over from Africa to Texas, is becoming an annual thing now, and it's really starting to affect a lot of people. And today it seems to be affecting my voice. I apologize. Now, during the space age, just within the past 50 years, several new Maria have been named. Mare Cognitum was partitioned from Oceanus Procellarum in 1964 and designated as a separate Maria. This particular region was the impact area of the American Ranger 7 spacecraft, the first successful American spacecraft to reach the moon. So the IAU renamed this portion of Oceanus Procellarum as Mare Cognitum, the sea that is known, in honor of the achievement. Now, lunar mountains are different. Earth's that are different than Earth's. Earth's mountains are continuously created by plate tectonics and volcanism, and are eroded by Earth's weather and oceans. Lunar mountains are created by a different process, impacts. Lunar mountain chains are the raised rims of impact basins. Individual peaks form at the center of large crater impacts, but in the case of basins, these are generally covered over by lava and we don't see them. But the mountains that form the basin rim have remained unchanged since their formation billions of years ago. Earth's mountains can be significantly altered within 100 million years, whereas lunar mountains have remained as they've been for the past 4 billion years. One of the most famous examples of mountains on the moon is the Alps, easily seen to the east of Plato crater, a very popular target. Oops, sorry. The Alps are part of the rim surrounding the Imbrium basin. And when you proceed further south, that rim continues as the Caucasus Mountains. Proceed even further south, the Apennine mountain chains. And then at the lower part of the Imbrium basin, the Carpathian Mountains. Now, the Cordillera Mountains surround the Oriental Basin on the extreme western edge of the moon, and these are very elusive mountains. They can only be seen about 1 day before full moon. A day or two earlier, the shadows are not there, and you cannot see the relief to identify the mountains. A day before full moon, the shadows are perfect. You can see them. During full moon, the shadows disappear, so the mountains are not seen anymore. So they play peekaboo, and we can only see them 1 day of the lunar month. Other examples of lunar mountains are the Jura Mountains that surround the Bay of Rainbows on the northwestern shore of Mare Imbrium. And some prominent mountain chains, such as the Western Crisium Basin impact ring that cradles Mare Imbrium, are unnamed. There are quite a few features on the moon that deserve a name but do not have a name. Now we're going to look at the types of craters on the moon. Now there's a classification system for craters, just like we have the main sequence where we classify stars by their spectral type. There's a main sequence of craters. A crater less than 16 to 21 kilometers in diameter is going to be a simple bowl-shaped crater. If the crater is larger than 16 to 21 kilometers, the dynamics of the impact that create it will create a central peak in the middle of the crater, and the outer walls of the crater will be so large and high that lunar gravity causes them to collapse and fall inward into the crater, forming a series of terraces. Then if the crater is over 300 kilometers in diameter, it's a basin. And here's some examples. Helicon and Leverrier on Mare Imbrium, just simple craters without central peak. Copernicus is a classic complex crater. Central peak, terraced walls, and then Bailey on the southwestern portion of the moon, classified as a crater on many old charts and maps, but modern understanding classifies it as a basin. Now, complex craters feature a central peak with collapsed terraced walls. Pythagoras up in the northeast allows us a slant view of this. The same with Moretus on the southern part of the moon, Geminus on the eastern part. Here our perspective looks at them in a slant, so we can see the altitude of the central peak and the texture of the collapsed terrace walls. Now, crater rays are composed of pulverized glassy material thrown from a crater by the impact explosion that created the crater. Crater rays fade after about 1 billion years and are an indication that the parent crater is young if the ray still exists. Rays are brightest near the full moon because they're very efficient at reflecting light directly back at its source, which in this case is the sun. Now, the Tycho ray system is the largest on the moon, spanning 2,200 kilometers. But there's a mystery. Toward the northeast, notice the railroad tracks, the parallel rays, and the odd south of the rogue ray to the southwest that is not aligned with the middle of Tycho. This is very curious because crater rays are thought to originate from the explosion that created the crater, the impact, and thus the rays should point back to the source. But we've got two very prominent examples of rays on Tycho that do not line up with the center of the crater. Now, monodirectional rays, such as those extending from Messier and Messier A, and the butterfly ray patterns, like the one extending from Proclus, are an indication of a very oblique impact, less than 5 degrees above the horizon. And with an impact like this, no ray material splashes in the direction the impactor arrived. Now, secondary craters are created by the impact of ejecta thrown by a crater's massive explosive formation. Secondary craters are shallow because the impact speed cannot exceed the 2.4 kilometer escape velocity of the moon. Secondary craters often lay in linear chains, and the majority of the craters smaller than 20 kilometers on the moon are believed to be secondary craters. But these craters can appear hundreds of kilometers from the primary impact, and associating a secondary with a specific primary can be a challenge. Now, there's a number of craters on the moon that are highly elongated. The classic crater is round, so elongated craters get our attention, but Hazel is actually created by multiple overlapping impacts, and the same with Ray E to E, the keyhole-shaped crater. However, Schiller, 170 kilometers long, is actually a single oblique impact that ripped a gouge in the side of the moon. And not all craters are round. Anaximander is this kind of heart-shaped. It's an overlapping series of craters. The same with Meton. It looks like a 4-leaf clover. It's actually a series of several overlapping craters where the interior has been filled with impact ejecta from the Embrian Basin impact and obliterated the inner walls, so they all merged together. And then there's Agrippa and Goten. One is kind of bullet-shaped, the other is bell-shaped. So not all craters are round. Then there's a class of craters called floor-fractured craters. And these started out as regular complex craters with a central peak, collapsed terrace walls, but the same magma chambers that fed lava flows that flooded the basins also flooded these craters from below through fractures in the floor of the crater and filled the interiors with lava, solidified into basalt, which then cooled, shrank, created the crack patterns. Looks very much like dry mud on a desert floor, but it's actually solidified lava. Now, pre-existing craters that were buried by the Mare forming lava flows billions of years ago are called ghost craters. We could only see them by the raised rims protruding above the lava field or the wrinkles in the lava created by the buried subterranean crater. Lamont is a very large example of this on the Sea of Serenity, the Mare Tranquillitatis. This is actually just north of the Apollo 11 landing area. Stadius is visible just above Copernicus, and Flamsteed P, about a 70-kilometer crater completely buried except for the very tips of its rim protruding above the lava field. There are chains of craters on the moon also. We call these catena by the Latin name, Catena Muller, Catena Davy, Catena Abulfeda. The theme is these were created by objects, asteroids, soft rubble asteroids or comets that got too close to the Earth and the moon system and were broken up by Earth's gravity. And instead of a single impact, they showered down onto the lunar surface in a stream of impacts. So we get a chain of craters instead of a single crater. Now, wrinkle ridges on the moon are known by the scientific name of dorsum or dorsa. And these are folds on the Mars surface where sheets of basalt have crushed together and buckled into a lengthy ridge that rarely exceeds several hundred meters in elevation, but can extend several hundred kilometers in length. Wrinkle ridges are usually named after Earth scientists. And the most popular wrinkle ridge is the Serpentine Ridge on eastern Mare Serenitatis. The Serpentine is the combined lengths of Dorsa Smirnov and Dorsa Lister. Dorsum Heim lies off the western shore of Mare Imbrium, and other unnamed wrinkle ridges look like frozen ocean waves in the horseshoe bay of Sinus Iridum. And unnamed wrinkle ridges arc around eastern Mare Humorum. Now, rills, scientifically known as rima or rimae, are grooves or channels on the moon that are appreciably longer than they are wide. Rills are formed by three different processes. Straight rills are formed by the slumping of land between two parallel faults. The crust is split apart by a volcanic dike or a vertical sheet of magma that pushed up from the moon's molten core, but did not breach the surface as a volcanic eruption. The land between these two faults collapses inwards and creates the linear fault, a linear rill. The arcuate or curved rills are created by the stretching of land near the edge of a mare. As the mass of the mare basalt slumps toward the middle of the basin, it pulls open the land near the mare shore. And the Rima Hippolis is a prime example of this. Now, sinuous rills are formed by flowing streams of lava, much like channels are cut in the earth by flowing water. But in this case, it's flowing lava, eroded these sinuous channels. This one is Rima Hadley, better known as the Apollo 15 landing site. Now, scarps on the moon, scientifically known as rupas, are formed by two processes. Some scarps are the surviving rim of an impact basin, like Rupus Altai here, the outer rim of the Nectaris impact basin, while others are created by land slumping on one side of a fault. An example of that is the upper feature, Rupus Cauchy, is actually a fault line, collapsed. And one of the most famous scarps on the moon is Straight Wall. We see the collapsed territory on the western side of the fault line has slumped the land down to where at sunrise, the scarp creates a shadow. whereas at sunset, it will be illuminated as a white line. Now, past volcanic activity on the moon is evident in the form of pyroclastic deposits, sinuous rills, ash deposits around cinder cones, and volcanic domes. This region, the Aristarchus Plateau, is basically a rectangular area that was built up by volcanic eruptions on the northwestern side of Oceanus Procellarum. Near the very center of the moon, there's a heart-shaped pyroclastic deposit in the hills north of Rima Hyginus. It has no name, so I call it the heart of the moon because it resembles a heart shape. Ash deposits around cinder cones can be seen in the small volcanic vents around the rim of Alphonsus crater. I think we're at a race to see if I can finish this before my voice quits. Okay, volcanic domes on the moon are bubble-like swellings or small shield volcanoes where highly fluid lavas formed low pancake-shaped structures. The Marius Hills on Oceanus Procellarum, prime example of this, dozens and dozens of these tiny small shield volcanoes. And a larger example, Mons Rumker on northern Oceanus Procellarum, a plateau raised up about 1 kilometer and covered with about a dozen small volcanic domes. So to conclude my presentation, I'm going to just stroll down memory lane and look at some of my sentimental lunar favorite regions on the moon. These are areas that have given me a great deal of pleasure for the past 50 years, and I hope you appreciate the geology and the features, their features and how they were formed now that you understand a little bit more about the moon. An early favorite for everybody, Plateau crater. Obviously different than most other craters. Well, craters are bowl-shaped, deep, round, usually have a central peak, but Plateau is unusual. It's flat as a parking lot and filled with dark basalt. Tycho crater, another favorite, normally seen because the ray system pinpoints it, but right at sunrise when the rays are not visible, the high power telescopic view shows something unusual in the area. The almost grainy, rusted-like appearance of the surface caused by hundreds and thousands of tiny secondary impacts of material blasted out of Tycho by the impact that created the crater about 108 million years ago. Tycho is fairly fresh. It was formed during the period of dinosaurs. And we can still see the tiny secondary impacts splattering the area all around Tycho. I mentioned the Aristarchus Plateau, the volcanic region built up by pyroclastic eruptions on otherwise relatively smooth Oceanus Procellarum. Endymion crater, another dark basalt-filled crater, reminiscent of Plato. I like this view because it makes me imagine I'm looking out a spacecraft window and I'm in orbit around the moon, just looking out toward the horizon. And Tycho crater, Copernicus crater seen from above. The ray structure, very prominent. Just sheets and streams of ray material splattered out in all directions. And the lunar terminator, as the sunset creeps across the moon. We like to observe the moon close to the terminator because the shadows are greater there, and it allows us to see the relief and surface detail, whereas during the full moon, the shadows are absent and much of this detail will vanish. And the region around Straight Wall, the very famous scarp that quickly becomes a lunar favorite for novices. Yeah, right square in the middle of the moon, the center of its disk, we have these three rill structures. The Hyginus rill on the left, Ariadaeus rill in the middle, and Rima Hypatia down at the lower left, lower right, at the bottom of the Sea of Tranquility. And just too much stuff in this picture to talk about, so we'll just enjoy the view, the heavily cratered lunar highlands that kind of preserve the way the moon looked 4 billion years ago before lava flooding filled in some of the basins and smoothed out other areas of the moon. This is pretty much how the entire moon looked like before the Maria were formed. And there's that ghost crater Lamont on the western shore of Mare Tranquillitatis. The wrinkle ridges radiating out from the ghost crater make it look like a giant lunar spider. And Cassini crater at the top, very unusual crater that completely surrounded by Imbrium lavas. The interior of it also flooded with lava that forced up from underneath the crater. Didn't spill over the top, over the edge, but came up from the bottom. So the lavas inside the crater are actually at a higher elevation than the lavas outside. And then subsequent impacts created the two craters inside of it, which give it the unusual snake eye appearance. And this is a study of how impacts age features on the moon. All three of these craters, Theophilus, at the upper left, at the upper right, Cyrillus in the middle, and Katharina in the middle left, are all about the same age. But Katharina formed first, and then the impact that created Cyrillus partially obliterated Katharina, and then here come Theophilus, the freshest looking one of them all, and impact ejected from it further ruined the other two craters. So although they're very similar in age, the older ones look very, very ruined by the impact debris thrown out by the younger ones. And a broad view of Mare Humorum. I really like this particular view because the floor fractured crater Gassendi up at the upper left, it reminds me of an oatmeal cookie. Kind of makes me hungry when I look at it. And the Serpentine Ridge on Mare Serenitatis, and the very unusual floor fractured crater Posidonius at the upper right. And a high view of the Nectaris Basin with Theophilus and Cyrillus and Katharina. And at the lower left, we see the beginnings of the Altai Scarp. And the high view of the Southern Highlands. And the very smooth plains of Mare Crisium. And Posidonius crater at the bottom, floor fractured crater, and up at the top, the kind of the bullseye pattern of Lacus Mortis, the Lake of Death. Copernicus at sunrise. And the crescent moon. The crescent that we see right after sundown, and the first Maria that appears, Mare Crisium, looking at us kind of like an unwinking eye, keeping an eye on the Earth. So to conclude my presentation, I'd like to say the moon is not a graveyard for dead philosophers and scientists, in spite of the names scattered all across its surface. The moon is a dynamic world filled with wonders and scientific delights. The moon is available for viewing most of the month. The moon does not require a dark sky. It is a backyard object, and the moon is the only celestial body we can observe at 1 kilometer resolution through a telescope. So there is much to love on the moon, and I invite you to come join me on my playground. So thank you very much for your attention, and I think we can go to the questions now.
Thank you.
All
Thank you so
righty.
much. Well, that was such a wonderful and comprehensive and full of details. I learned so much about it, about your presentation, although I've read a lot about the moon as well, but it was a good learning experience for me. And for us amateur astronomers, actually the moon is still a favorite object to image, and I'm amazed by the quality and the beauty of your images, and we are inspired. Maybe we can try it. Maybe the first question I would like to ask is, what is your setup, Robert, for your imaging, and what software do you use?
Well, my majority of my lunar imaging is done with the Celestron C11 EdgeHD. Excuse me. I've used various cameras. My favorite is the Skyris 236, but the darn thing quit on me after years, and it's no longer in production, so I can't get a replacement. So right now I'm using a QHY 174M, I think it is. I get the 174 and 178Ms confused, but I think I'm using the 174M now by QHY. Traditionally, I put a 1.5x Siebert Optics Barlow in the optical train too. So I'm actually operating at about f15. I consider the Siebert Optics Barlow a kind of one of the best kept secrets in planetary imaging, lunar imaging. They are extremely good Barlows. And it's almost like it's a integral part of the original optics of the telescope. And it works so well. They're made here in the United States by a fairly small company called Siebert Optics. And I just love it. So I've also used a Skywatcher 180 millimeter Maksutov with very great success. The images through the 7-inch Mac are almost as good as what I get with the Celestron 11. I also have a Celestron 14, but its performance on the moon is hindered by my local seeing. The larger aperture of the telescope sees more turbulent seeing air cells, and although the telescope is theoretically capable of better resolution, because of my local seeing, its aperture is actually a hindrance. So the good sweet spot is the C11. It's looking through fewer turbulent air cells, and I get better resolution with it. So that's basically what I use. C11 planetary camera, easily available from various manufacturers, and a really good Barlow. Software-wise, I use Fire Capture to capture the videos. Depending upon how good the seeing is, I will capture either 3,000 or 5,000 video frames. That'll give me a video file size of up to about 11 gigabytes, but you do what you got to do. That video is then processed in AutoStacker to create a single TIFF image, which I then import into Photoshop for further processing, adjusting the tones and highlights and bringing up the shadows and getting rid of any odd artifacts that pop up because of the image stacking process. So the processing will often take about a half an hour per image, to comb through it and straighten it out, get everything correct. I see many images posted on Facebook of the moon that are technically better than what I can do here. I mean, other people in other areas of the world have much better seeing than I do, and their data is really good, but they don't completely process the image. So that's a shame. When I deal with lunar processing, like I said, it often takes a half an hour just to process a single image. So, but it's worth it. The end result ends up looking like something taken by a NASA spacecraft.
Thank you, Robert. Another software that I would like to ask is, before, when I was trying to time my observation of the moon, I used there's a free software called, I forgot the name, Lunar Map Pro or something. It's still available.
Oh,
Yeah. I forgot the name, but it's a free software.
Virtual Moon Atlas.
A virtual moon atlas, yeah.
Yes, it is available. It's gosh, I think there's something like 500 million downloads a year of that software. Yeah, it was created by some Frenchmen, and it's extremely good. I use it myself all the time. In fact, if you can see, it's on the main screen of my desktop as we speak. I had it up there in case I had a little memory block and couldn't remember a crater name, and I'd look over there and see what it was. But
I'm so thankful for that software. And a related question to that, Robert, is when should we be looking at when should we be looking to see features on the moon that can just be seen at the moon's edge when it is positioned well? Is it something to do with the libration, like, for example, Mare Oriental or something like that?
Oriental comes and goes, yes, because of libration. Oriental is very close to the western edge of the moon, and it's one of the features that, as the moon rocks back and forth just a little bit throughout the month, the moon kind of nods back and forth about 7 degrees, and that's just enough to hide Oriental at sometimes of the month. Other times it'll roll around in the view. But the main thing is follow the terminator. The vast majority of the moon is always visible, only along the rim. The limb where we'll have these effects from libration, where certain features will be hidden. But for the rest of the time, the moon is features of the moon are visible all the time. And we follow the terminator where the shadow line is, because the low sun elevation will provide the shadows and the relief to be able to see these features. At full moon, you would think, well, we'll look at the moon during the full moon because you can see the entire moon. But the flat face-on illumination eliminates the shadows, and many features will disappear. You can't even see them. So follow the terminator as the moon goes through its phases throughout the month. And along the shadow line is where you're going to see the most detail.
Robert, just a follow-up question about your image processing. Do you have a website wherein we can access tips for you on how to process our lunar images?
I had a website at one time, but during the COVID period, I got involved in other activities and I let it lapse. It is currently not active. So right now I just post my stuff on Facebook every day. So if you go to my Facebook site, look me up, Robert Reeves, and I'm the Robert Reeves with a telescope. Click on that and start going back through my timeline pictures. You'll probably come across about 1,000 pictures of the moon. So that's probably the best place to look at them. Eventually, I'll get my website up and running again, but right now it is inactive.
So let me leave the questions about the imaging. There's a question here. Why are there more impact craters and less Marias on the lunar far side compared to the near side?
In my presentation, I mentioned that the crust on the far side of the moon is thicker than the crust on the near side. The near side crust, being thinner, allowed the lava eruptions to erupt through the surface easier than on the far side. And basically, the far side is too thick and it corks off the lava eruptions. So there's very few of them on the far side, whereas on the near side, the basins formed on a shallower crust, and the fractures were able to reach the magma chambers and allow the lava to come up through. On the far side of the moon, it is simply too thick. The basin fractures didn't reach deep enough to allow interior magma to come up.
Thank you. Next question is, are there any new features or craters that have shown up on the moon over the past years? What about transient lunar events?
The formation of large craters is a fairly rare event. During the history of observational lunar studies with a telescope, no large new crater has been found. However, spacecraft images of the moon, spacecraft in orbit repeatedly photographing the moon now have gone back over areas repeatedly, and we can spot new craters, small craters, the tens of meters in size that weren't there before when the spacecraft initially made its first mapping passes. So we are seeing impacts on the moon. Additionally, we're getting really good at being able to see meteorite impacts on the moon telescopically using video techniques, video cameras that monitor the moon and see the flashes of the impact. Now, these are fairly small impacts that create craters just tens of meters in size. So it's not something we're going to be able to see in a telescope, but this is an ongoing process. And there are a number of programs, both NASA and amateur, that monitor the moon for these impacts, and several hundred of them have been recorded. So impacts on the moon are ongoing, but fortunately the large, massive asteroids that would create huge craters, they're pretty much all used up. They've done their damage. The solar system is a lot safer right now. So we're not going to be seeing impacts like that. But transient lunar phenomena, I was just talking about that the other day with somebody, how that phenomena seems to have faded away. Now, I don't know if this is a function of fewer people looking at the moon and not seeing things that are there, or whether we simply understand the moon better and recognize these phenomena for what they are and not something strange and unusual. But the transient lunar phenomenon thing that was quite popular back in the 1960s seems to have faded a bit.
It's been a long time since man has visited the moon. But the question here, what can you say about NASA's Artemis mission to bring astronauts back to the moon this decade?
Well, I hope it succeeds. I hope it gets the adequate funding and management to make it succeed. But I have a sneaky feeling that when they get there, they're going to find one of Elon Musk's starships waiting for them, because Elon's liable to beat them to the moon. Yeah, the whole business of going to the moon in a big rush and then just abandoning it 50 years ago, that left a bad taste in a lot of people's mouths. But I'm glad that we're finally getting the program back in action and getting hardware ready to go back to the moon, although I'm not in complete agreement with how it's being done. But I really think that between NASA and private enterprise, we will be back on the moon within 10 years.
Thank you. You mentioned in your lecture that if the moon didn't form, life on Earth would not have been possible. Can you kindly explain this connection?
Well, the life formed in the oceans originally billions of years ago. And if the moon didn't exist, the oceans would have no currents, no tides, no movement. The oceans would be stagnant. And stagnant water doesn't necessarily work very well when you're trying to create biology. It's kind of rotten, to put it in a simple word. The mixing of the water and the chemical elements in the early oceans were driven by the tides and the currents that were created by the lunar gravity. So without that, it's very possible that the chemistry that created the early life in the oceans might not have happened. So I'm not saying the moon is directly responsible for the creation of life on Earth, but it certainly would have been extremely difficult for it to happen without the moon. So it's kind of a question we really can't definitively answer because, well, we weren't there back then, but we can take a good educated guess that without the moon gravity stirring the Earth's oceans with tides and currents, the chemistry that created life on Earth, well, either wouldn't have happened or it would have been a different type of life. We would not necessarily be here in the same form that we are now.
Thank you, Robert, for that explanation. Here's a different question. Well, we experience this a lot now, especially with the era of social media. Everybody has their own opinions. What do you tell people who believes in the moon hoax, that the Apollo moon landing is fake?
Well,
or fake. Yeah.
I'm kind of at a loss right there because my initial reaction is words and statements that may not necessarily be appropriate for a white audience. No, to put it in kind words, I would urge them to do a little bit more research, put their thinking cap on, and realize that man is a pretty smart creature on this earth. We have done amazing things. We are capable of developing enormous technologies. Just kind of look around and figure out what's wrong with your thinking here. Why do you believe this hoax? What's your political agenda here to drive such a thing? Because man accomplished one of the most amazing feats of technology and exploration within our own lifetime, and you're too blind to recognize it. I'm sorry. I don't have any words for you. Just please go think about that a little while and figure out why you're so negative about such a thing and why you don't believe something that happened. It's almost on the same plane as Holocaust deniers in World War II. Clearly, this happened. It was part of history. Millions of people experienced it, yet some people ardently deny it. And the same with the moon landing. I'm sorry, you're in a minority. You're wrong. Go figure out what's wrong with your thinking, and maybe you'll have a better outlook on the world.
Yeah, fully agree, Robert. It's very difficult nowadays with all of this happening in social media.
Yeah, that's the problem with social media. It gives every nut job an equal platform with the people who do tell the straight story and the truth.
A related comment regarding the importance of the moon. Another importance, this is actually a comment from one of the panelists. Another importance of the moon is that it is what keeps our poles intact. The magnetic poles, north remains north, south remains south. Is that okay?
I really haven't heard anything about the moon affecting the magnetic poles of the Earth. I've always been under the assumption that the magnetic field of the Earth is driven by our own interior iron core, but I am not a geologist, so I can't definitively say. But my personal feeling is that I don't think the moon has anything to do with Earth's magnetic field. The moon interacts with our magnetic field by once every month, it passes through the Earth's geomagnetic tail, which is our magnetic field stretched out in space by the solar wind. And so we affect the moon, but I don't think the moon affects, we affect the moon magnetically through that process, but I don't think the moon affects us.
How about the effect on the tides? Is that also relevant to life here on Earth?
Could you repeat that? I lost.
The effect on tides, ocean tides.
Oh, tides. Well,
Yeah.
there's that is the most obvious effect that the moon does have on Earth. I mean, the ocean tides, like I said, without the moon creating the tides and ocean currents, the oceans would become stagnant and die. And that would pretty much end things on Earth. I mean, our whole ecosphere would collapse, and we would be in a world of hurt. Human civilization would be radically, drastically altered. And I can't see any good outcome from something like that. So the moon is very definitely a positive influence in that it drives the tides and ocean currents.
So here's, thank you, Robert. Here's a different question in relation to the media again, I think. What do you think about the media hyping up the full moons with names like blood moon, super moon, micro moon, and the monthly names given to it? Like, for example, here in our country, just recently we had the pink moon and the strawberry moon, although we are not using North American terminologies. Given the prevalent theory of the origin of the moon being that it was born after a small body collided with the Earth and reformed from the debris, rather than being captured, does that make the Earth-Moon system really a double planet system? This is a different question. So first question first.
Okay,
what
well,
about,
the first one,
media hyping, yeah.
Yeah, about the media, I view it with some degree of amusement. Yeah, on one respect, I think it's kind of silly, but in another respect, at least it's getting astronomy, the moon, getting people to look up at the moon. It's getting attention, and that's a good thing. Anything we can do to get people looking up and becoming interested in the sky and knowing what's happening in the sky, that's a good thing. Although the designations of super blood, whatever moon, well, it's not scientific, but it borders on the silly in my thinking. But like I said, if it gets people looking at the moon and thinking about the moon, that's a good thing. Now the other question that you were
is the Earth-Moon system really a double planet system because of the
yes, it is actually a double planet system. The center of mass of the two worlds, the moon and the Earth, is actually below the Earth's surface. As the moon revolves around the Earth, the center point between them is I forget the figure, but it's several hundred miles below the Earth's surface. So we're kind of wobbling around each other. So this the moon is slowly receding away from the Earth. Like I said, originally it was about as close as geosynchronous satellites are today, but it's been slowly receding away because of how the Earth's tides interact with the gravity of the moon. And the moon is actually today about 1 meter farther away from the Earth than it was when Neil Armstrong landed on the moon. And this recession will continue until the moon reaches a distance of about 500 million miles from the Earth. But by the time this happens, the sun will have ballooned up into a red giant and the solar system won't exist anyway. So we're not going to worry about the moon getting too far away. But the curious thing that excites me is that the timing of when we are here on the Earth, human beings, smart enough to understand what's happening in the sky, is the exact same time when the moon is just far enough away to create a solar eclipse.
Yeah.
If the moon were closer, it would blot out the corona and we wouldn't see a solar eclipse. If the moon were further away, it would be all annular eclipses. We would still see no corona. So the timing of Earth and moon being at this particular distance apart, just when we are here evolving enough to understand science and create the science of astronomy. I think that's an extraordinary coincidence.
Thank you. The third question is, how would you know that a meteorite came from the moon?
How would I know if?
How would you know if a meteorite came from the moon?
Oh, if the well, actually, I have one. I was gifted a lunar meteorite. The samples that have been returned to Earth give us a good ground truth about the composition of the moon. We know through space age studies what the general composition of the moon is, and we can match that up geologically and chemically with various meteorite samples, and have identified a good number of them as lunar meteorites. The same with Mars. There are Martian meteorites that have been identified by the unique chemistry and geology of the sample itself. Yeah, we can identify some meteorites as positively having come from the moon. And it stands to reason that if something strikes the moon hard enough, it will blast material off the moon in excess of lunar escape velocity, and a certain amount of that is going to fall to Earth. So quite a bit of lunar material has fallen to Earth because of this process.
Thank you, Robert. This is from Jason Rollion. Good day, Sir Robert. I would like to ask about what could be the best telescope that we can use to observe the moon. Something that is student friendly, especially like me who is into astrophotography.
Well, I work for the Celestron Telescope company, so I get that question a lot. and my answer is based on what is your budget, because you can get a really nice little telescope for several $100s that will give you very pleasing views of the moon. But when you get into photography, there are certain technical requirements that you need, and the telescope becomes more complex and expensive. So just for general views of the moon, something like our Star Sense Explorer telescopes will do nicely with a additional higher power eyepiece. But if you want to do lunar photography, you're going to have to get into something like a Nexstar 6SE or a larger telescope, so you can attach a camera to the telescope and control it properly and get decent magnification. So there you're starting to get into things that are in excess of $1,000. Astrophotography is a very slippery slope. You get into it, you find you're going to be spending a lot of money. It's just the nature of the way it is, the technicalities of it. But like I said, good visual views of the moon can be obtained with inexpensive telescopes, but photography is going to require an investment, minimum of $1,000 to get a good enough telescope to get satisfying images of the moon.
Thank you, Robert. I remember I started with a 5-inch SCT, but I had a good mount, and I think we were using webcams during that time.
Yep.
And we got very decent pictures.
We've come a long way.
Yeah. I have another question, Robert, regarding image processing. I noticed some people would like to image the moon, like the full disk image of the moon, and try to come out with a color image. What do you think about that idea? to bring out the so-called color in the moon?
Well, the people can image with color cameras and process and stretch the colors in Photoshop and actually get various color tones on the moon that are indicate the mineral content on the moon. This is becoming quite popular now. It does require a good color camera and a good number of exposures to stack together to get good bit depth, so you can stretch the colors without the image posterizing on you. But it is quite useful in identifying the various mineral content on the surface of the moon, because each color represents a different type of chemistry, different type of mineral. So this can be done with fairly simple equipment, DSLRs and a Schmidt Cassegrain telescope, and stacking the images in the same processing that we've been doing, and then stretching it in Photoshop. And you can identify different chemistry on the face of the moon that way.
Nice. That's great. Robert, thank you very much. Are there any other questions from the panelists?
Yeah, we've been going at this a while, haven't we?
I just
realized.
Yeah. You're okay, Robert.
Oh yeah,
you
I'm
have a
fine.
drink of water. You have a drink of water there.
Well, yeah.
I was about to suggest that you should wear a surgical mask if it's really dusty over there.
Well, my wife does when she goes outside. It's that bad. We're hoping that by Monday it'll settle down a little bit, but right now it's pretty bad. I can even feel it in my eyes.
Robert, I do have a question for you. By the way, I'm Edwin.
Hi.
Imelda's other half. Yeah. And my question is, what is your favorite feature of the moon and why?
Oh boy. It's like asking which one is your favorite child. I can't answer that. I showed a whole bunch of them at the end of the presentation, and each of them is unique and created by a different force on the moon, and presents a different landform. And there's just so much there that is unique and unusual that I just can't pin down one particular one. I can't say this is the absolute favorite. I can't do it. No more questions? Everybody happy?
Thank you so much, Robert. Actually, I'm really inspired to image again and bring out my old C11 and try to get high resolution images of the moon. But of course, my main problem here at my location is also the seeing.
Yeah.
We have very poor seeing. Unlike Mr. Chris Go has a very good seeing in Cebu, and he has also very good high resolution lunar images.
Yeah, he does real good on the moon too. I'll admit that. In fact, he taught me a trick or two about how to do it. So I owe him a lot for my success. But it's been an awful lot of. It's been a lot of fun talking with you all. I've really enjoyed this, and I don't know how many people were tuned in, but I appreciate that. But I've really enjoyed talking to you all, and I hope a little bit of what I've been discussing inspires you to go out and look at the moon and appreciate the geology and the vast differences between different areas of the moon, and understand how they were created and came into being. So there's something up there. It's just beautiful. It's between science and art. You can appreciate it just for how pretty it is, or you can appreciate the geology and the science behind it. So a little bit of something for everybody. So I hope I pushed you toward it.
Thank you again so much, Robert. Despite the difficulties, you finished your talk, and we really appreciated it. And as a token of our appreciation, the Astronomical League of the Philippines would like to present to you this certificate of appreciation, and allow me to read it. The certificate is presented to Robert Reeves for his invaluable insights, experiences, and expertise shared with the participants of the webinar entitled Observing and Understanding the Moon, held as part of the ALP Astronomy Expert Speaker Series 2022, given this 18th of June 2022, signed by the President, James Keventy, and Vice President, yours truly, Jose Francisco Aguilar. Thank you so much, Robert.
Thank you.
And before we go, can we take a group picture with all of us? Who will take the picture?
Let me take the picture. I can do it, guys. I can do it. All right.
Full frame, everyone in one frame, Peter.
Yeah, in one frame.
Okay, then.
All right. So say cheese, guys. 1, 2, 3. Okay, one more time. Have more. Okay. 1, 2, 3, cheese.
Robert, thank you
Got it.
so much again. I really appreciate what you've done for us. You know, we observed the moon, but I think Edwin and I are saying, after listening to your talk, we will view the moon very differently.
Thank you. I appreciate that. Thank you for inviting me.
Yeah.
Thank you,
Thank you
Robert,
so much.
for
Thank you
joining
so
our
very
webinar.
much.
Robert.
Bye-bye.
Thank you very much, Robert.
Thank you,
Bye-bye.
Robert.
Bye.
Thank you.
Bye.
Thank you.
Thanks,
Take
Robert.
care.
Robert.
All right.
Hey, bye.
Bye.
Bye. Bye, guys.
Ken, are we gonna have an after?
No, I'll just share one more thing. Can you hear me?
Yeah.
Yeah. So before we conclude today's webinar, I would like to thank all of our attendees for joining us. We'll be sending you certificates of attendance for today's webinar by email to all the registrants who were able to join us today. This is the 5th webinar in our ALP Astronomy Expert Speaker Series for 2022. We started this series last April 23 with Dr. Jay Pasakov, then Mr. Zolt Levay, Mr. Joe Rayo, Mr. Fred Espenac, and last, of course, is Mr. Robert Reeves. And we are really grateful to all our esteemed and prominent speakers who very generously gave their precious time to share their knowledge and expertise to the world amateur astronomical community. We can never thank you enough. And if you miss these webinars, you can actually review them again on our YouTube channel, Astronomical League of the Philippines. All of the previous webinars can be viewed there in our Astronomical League of the Philippines YouTube channel. Thank you. And lastly, we would like to announce our next webinar, which is scheduled on July 31, 2022, Sunday at 10 o'clock Philippine Standard Time. And in the United States, this will be on Saturday, July 30 at 10 p.m. Eastern Daylight Time. Again, we will have another notable speaker, the world-class astrophotographer, Mr. Ken Crawford, who will speak on Going Deep for Science from My Backyard. We will be posting the registration link and details of Mr. Crawford's webinar at our Facebook page and webpage, the astroleaguefields.org. Please join us again to this free and very interesting webinar. Thank you again. Take care, everyone, and clear skies always. Thank you,
Yes.
everyone.
Bye,
Thank you.
everyone.
you.
Thank you.
Thank you.
Bye-bye.
Bye.
Thank you.
Hope
Thank
you
you,
guys
Eric.
can all join in the next meeting.
See you in the next
Yes.
webinar.